All right, good morning, guys. For today's assignment, I'm going to have you guys do another one of these. So I'm going to go over with you so you guys know exactly what to do, and I will even do a few examples. All right, so this is just going over the same stuff that I talked about yesterday. So this first slide, it says, assume that a standard number cube is rolled. So a standard number cube has 6 sides, and each side is 1, 2, 3, 4, 5, or 6. It says, find the theoretical probability of each event below. Drag each event to the red box that has the correct solution. So remember, theoretical probability is what should happen. So I'm going to do, let's do this one. So I'm going to do this one. Rolling a number less than 3. So that's not including 3. So the only options you have are 1 and 2. So the theoretical probability of this one right here would be 2 over 6. However, there is not a 2 over 6 on here because you have to reduce it. So 2 over 6 reduces to 1/3. So you're going to move E right over into this box. All right, and now we are going to do rolling a number greater than 2. So that leaves us with 3, 4, 5, and 6. So that's 4 numbers out of a 6 sided cube. So 4 over 6, that would reduce to 2/3. So you would move that over here. So that's what you would do for all of those. So this is just normal probability. And then here, so when it says rolling a 2 or a 5, just 2 or a 5s. What's that probability? On this slide, it says Jamie spun the spinner shown 30 times and recorded the frequency of each result in the table below. Use the table to complete the statements in the orange box. So it says the experimental probability of spinning a blank is 1/5. The experimental probability of spinning a blank is 4/15. So in these boxes, you're going to put either if it's stars, stripes, dots, or blank. Blank means these sections right here. So in order to figure these out, you have to put these in the experimental probability format. So the first one I will do for you. So, okay, so what did happen? So Jamie spun the spinner 30 times. So out of those 30 times, she landed on stars 4 times. So the experimental probability of that is going to look like 4 over 30. Well, you have to reduce that. So to reduce that, you have to find a common number that you can divide out of both of them. Well, you can divide a 2 out of both. So if you divide both by 2, you end up getting 2 over 15. So I would do that for each one first, and then you have your answer. So the experimental probability of spinning a blank is 2/15. Well, we just got it. It's stars. So you're going to type stars in that box. So that's what you're going to do for each of them. And the last slide, so it says Miguel or Miguel? That's a Q? I don't know. Spun the spinner shown 100 times and recorded the frequency of each result in the table right here. Use the information to drag and drop the pieces to complete the table below. So here's our spinner with 1, 2, 3, 4, 5. And the frequency means, so the 20 for the 1, that means out of the 100 times that she spun, 20 times of that it landed on the 1. So experimental probabilities for spinning a 3. Okay, so for spinning a 3, what actually did happen? So that would be 22. She landed on 3 22 times out of 100. Well, if you reduce 22 over 100, that is 11 over 50. So that is what this first one would be. And then the theoretical probability of spinning a 3, well, that is just what should happen. How many numbers are there? There's 5. What are the odds of landing on a 3? Well, there's only one 3, so 1 out of 5 times. So that is how you would do this slide. All right, if you guys have any questions, please let me know like always.